Hello and welcome guys. It's been a long day. We made the previous video on the dynamic programming. Now I decided to make some kind of different video on stacks and queues. So let's start with today's problem. This is about finding the maximum rectangular area of a histogram, and this we're gonna solve using stacks and queues, and hope you're gonna enjoy this video as well. So hi guys, my name is Omerta. You're watching Developedia, and to be a part of the family, please subscribe. So we have this histogram which has different heights at different indices. At 0 it has 6, at 1 it has 2, something like that. And you were asked to find the maximum rectangular area within the histogram. By that, what I mean is that if you consider a rectangle like this, in the left diagram, this is a valid rectangle because it lies within the histogram itself. But this one exceeds this bar of length 4, of height 4, and that's why this is not a valid rectangle that we are looking for in this example. Now, give this problem a try, pause the video for a while, and then keep watching for a solution. Alright, now let's start from the basics. Now, if you want to calculate the area of a rectangle, the best thing you can do is that you're gonna have to take a height and then you get the base and multiply the height times base to get the area. Now the way you're gonna do in here is that, let's say you consider one bar. So let's say you consider this bar, and let me mention you guys that all of the bars are of width is equal to 1. Alright? Now, if you have this bar, its height is 4. Now, you consider the leftmost bar which has a height of greater than or equal to this height, which is 4. Now, what is the leftmost bar from this which has a height of greater than or equal to this? This is 5, right? So therefore, the L or left is going to be our index 2. Now, what's going to be for the right? We're gonna have R is equal to 4 because after this we have 1 which has a height lesser than this. So we're gonna take the leftmost bar which has a height greater than or equal to this, and we're gonna take the rightmost bar which has a height of greater than or equal to this. And there shouldn't be any discontinuities in the between, and by discontinuity I mean some bar that has a height lesser than this 4. Now once we have this thing, we can apply formula of this height times width to find the area of the rectangle, and the area of this rectangle is going to be h times r minus l plus 1, which is the width. In this case, this is 3, and by that we find the area to be 12. Now let's try to analyze the complexity for this solution. Now the complexity to calculate width of each rectangle is going to be O of n. The reason is that for each bar, we're going to approach left and we're going to find till what point we find a bar which has value lesser than the current bar that we are considering. So therefore, for finding the left, it's got to be O of n, and for finding the right, it's got to be O of n in turn. So therefore, the total complexity for finding the width is got to be O of n. Now the total number of such rectangles is got to be n as well, because we're gonna have to do the same thing for each and every single bar, and then we're gonna have to take the maximum out of m. So therefore the overall complexity is going to be O of n times n, which is O of n squared. Now this is definitely not the proper or the best solution, and we're gonna have to optimize it. And let's take a look. Can we improve? Yes, whenever you ask this kind of question, the answer is definitely yes, you can. And the way you can do this is that you're going to have to use a stack. Now, how are you going to do that? So let's have a few thumb rules first. So the first thing is that each element should be pushed in or popped out of the stack exactly once. By that, what I mean is that if you have n elements in total, and by that, in this case, in the histogram, you're going to have n bars. So each bar is going to be pushed into the stack exactly once and popped out of the stack exactly once. And the computation of each element will be done only while push or pop. So by that what I mean is that if you do the computation while pop, let's say for example, then in that case if your operation is O of 1, then you're gonna have exactly the complexity of O of n times 1, and therefore your overall complexity is going to be your magical time complexity O of n, and this is the best time complexity possible for this kind of solution. And you can actually understand it. If you have n bars, you're gonna have to traverse through them once at least at the minimum, and therefore if you can solve this in O of n, this is gonna be the best you're gonna get. Alright, now let's take a look at the algorithm, how you're gonna do it. So first, you initialize an empty stack and a max area, you say that it will be 0. Now remember, the stack we're gonna use is gonna store the indices and not the heights itself. Now what you do is that for all the heights in the histogram, you pop elements out of the stack until the stack is empty, or the current height that is at the top of the stack is larger than or equal to the value that you're going to insert into the stack. And then once you do that, you keep on popping the elements and you do the calculation while they pop, and the calculation is you update the max area using the formula that I had mentioned before, which is height times width, and then you push the current index into the stack. So by that what I mean is that the stack is going to be in such a way that you're going to have all the values inside the stack in ascending order. And after that, once all the elements are pushed in the stack, what you do is that you keep on popping elements out of the stack until the stack is empty. And the way you're going to do is that you pop elements out of it, and once you pop one element, you update the max area and then you return. That's pretty much it. That's pretty simple. Now let's take a look at the code for this same. Alright, so the code for this problem is pretty simple. What you do is that first you have a histogram which has the values for the corresponding heights, and then in this get max rectangular area, in this function what you do, you first initialize an empty stack and then you have a max area. Then after that you push all the elements in the stack exactly once. Therefore, you have a complexity in the pushing is O of n, and then you keep on popping elements out of the stack while it's empty. Until it's empty, and therefore this gives rise to O of n complexity as well. And if you're doing something of constant time operation inside, so in that case your total complexity is going to be O of n. And what you do in this case is basically, while you have the stack not as empty, or the top element of the stack has a value greater than the current element that you're going to push in the stack, what you're going to do is that you keep on popping elements out of the stack and you update max area. Now let's take a look at this function first. This is update max area. So this function, what you do is that you pass the max area, which is the current value of the max area, which you have it here. Then there you have the stack. You pass the address, because whatever you're going to do in here, the change is going to have to reflect in this function as well. And you pass the rightmost element that you are currently considering. Then you consider the height of the current bar, and that you do by histogram of stack.top and you pop the element, and thereafter you consider the left and the right index of the bar of the rectangle that you're considering right now, and then you compute the maximum area by this formula, h times r minus l plus 1, and then you take the maximum of this and max area, and that's what you return. And there you have the max area. And after once this is over, you push the current element in the stack, which is the rightmost. And remember, the rightmost is index, it's not the value of the height itself. And thereafter, once all the elements are pushed in the stack, then what you do is keep on popping elements out of the stack until you have the stack as empty. And once this is done, you follow the same formula in here to calculate the area, and thereafter you return the max area, and that's what you have in here. Now let's run this code. 12, yeah, definitely. In this example, if you take a look, in this example, if you take a look, you're going to see that this is the maximum area that you're getting out of this example. So therefore, our solution actually works. Alright, now let's try executing the Python code as well. Alright, this works pretty cool. And With that, guys, we come to the end of this video. I know this is a quick tutorial. This is not a very large one. Please subscribe to our channel and give us a like if you really enjoyed it. The code for this is going to be present in the GitHub repository. And please be a part of our family by following us on Facebook as well. Thanks for watching the video. Peace.